Hi and welcome. I'm trying to learn particle physics, today Paritysymmetry, and after we've done that we're gonna do what was it? Lunge training. Lunge training. And if you participate in the lunge training, then it's better to honest. Chen Shung Wu's broken mirror, so we read it already 3 or 4 times in the previous parts, but now we're here just to make a video about what is Paritysymmetry. You want to say that we actually know it quite well. And mirror symmetry also. It was an investigation of the weak force by Chinese-American physicist Chen Wu that provided one of the most profound demonstrations of the importance of broken symmetries in particle interactions. One of the most basic symmetries we know of is mirror symmetry. In particle physics, this goes by the name of paritysymmetry, a principle that says particle processes, collisions, decays, should happen in the same way if all the positions and orientations of the particles involved are flipped in the mirror, so basically the steps. In 1956, theorists Tsung Dao Li and Yang Chen-Ning showed that paritysymmetry was valid for interactions involving electromagnetism and the strong nuclear force, but we found no evidence for it holding in interactions involving the weak nuclear force. In 1956, Xian Wu designed and built an experiment at the US National Bureau of Standards in Maryland to test Li and Yang's idea by looking at the directions in which cooled cobalt 60 atoms trapped in a magnetic field emit beta decay products. And sure enough, she found an asymmetry. Paritysymmetry was broken by the weak interactions. Okay, the information we want to say is, first we want to do a video about paritysymmetry. Paritysymmetry in particle physics means that if in another room all the atoms are set up with the same orientation, same orientation and position, all the same way, same position, same orientation, all the same setup, basically like a mirror in another room, all the collisions and decays should happen in the same way. This is the setup. And I'm going to say that Tsung Dao Li and Yang Chen-Ning, no, we have to say his names. Tsung Dao Li, it's actually not the time. Tsung Dao Li. Tsung Dao Li. And Yang Chen-Ning. Yang Chen-Ning. Yang Chen-Ning. Yang Chen-Ning. Yang Chen-Ning. Tsung Dao Li. Yang Shen. Yang Shen. You mean Xian and then Shen. Yang Shen-Ning. Yang Shen-Ning. Yang Shen-Ning. Yang Shen-Ning. And Tsung Dao Li. Yang Chen-Ning. Yang Chen-Ning. And Xian Wu. Xian Wu. Xian Wu. Tsung Dao Li and Yang Chen-Ning. Tsung Dao Li, Yang Chen-Ning. Yang Chen-Ning. Tsung Dao Li and Yang Chen-Ning said in 1956 that regarding the strong nuclear force and the electromagnetism, all happens the same way, with decaying collisions, whatever these atoms could do if it's flipped, but not the weak nuclear force. And in the same year, 1956, did Xian Wu built an experiment. She took cooled cobalt 60 atoms, put them in between an electromagnetic field, cobalt 60 atoms, trapped in a magnetic field, just magnetic field. Trapped them in a magnetic field, and observed the beta, and observed in which directions, maybe we mean the directions not left or right, sondern to up and down or to up and down quarks. Maybe that means something like that. So let's just stay away from it, maybe completely. All what we're telling there is not that complicated, so maybe we should not go that much into details. and was looking how the beta decay was happening. Maybe that's all. We could say, and looked into which directions the covered 60 atoms, the cooled covered 60 atoms were doing the beta decay. So the decaying of, here's now beta minus plus set, of neutrons into protons, or from protons into neutrons. And actually, the weak nuclear force didn't happen. So, do we know it? It was Zhong Dao Li and Yang Shen Ning. Zhong Dao Li, Yang, how's it written? Y-A-N-G, Yang Shen Ning, and Qian Xiong Wu. That's right. I'm going to stop the second camera. And that is then according to Richard Webb's, we said it. It is Richard Webb. Richard Webb's Physical Understanding Limited Building Blocks. Yang Chen Ning. Yang Chen Ning. Paritysymmetry. In particle physics, paritysymmetry is like mirror symmetry. So if we have the same setup of atoms, basically mirror, same orientation, same position, all the same, they technically should decay and collide and whatever these atoms are doing in exactly the same way as in behind the mirror, so in the upper room with the same setup. And in 1956 did Zhong Dao Li, Yang Shen Ning. Paritysymmetry in particle physics. It's basically like mirror symmetry. We have the same setup of atoms, basically mirrored. So in one room we have few atoms, in the other one same atoms, same orientation, same position, same setup like a mirror, same thing. And now it is the idea it should happen all the same as in the other room. It's all the same setup, the same colliding, the same decaying, all. And in 1956 there were Zhong Dao Li and also Yang Shen Ning, and they prognosed that that is true for the electromagnetism, what is happening with the electromagnetism, and also for the strong nuclear force, but not for weak nuclear force. And in the same year, 1956, did Qian Wu then make an experiment. She took cooled cobalt 60 atoms and trapped them in between a magnetic field. And then was she looking into which directions these cooled cobalt 60 was beta decay. So protons into neutrons, neutrons into protons. And actually, she found out the weak nuclear force does not happen the same way, even if it's all the same setup. And that is according to Richard Webb's Particle Physics Understanding Reality's Building Blocks, page 34. Now, I think that is all right, what I said there, but according to what we have here, the problem is not what I just see now. This was pretty detailed, and it's not written so detailed. I just have a feeling in my gut that if we would know all about it, we would see that some things were not right. Now, with all what I have here as Suez, I don't think we have done much interpretations. It feels like a bit that can't be all true what I said. It's too detailed. The informations are not enough to make such a detailed and simple explanation. So there has to be something missing. Maybe not. That means we're going to come back to that video and going to look at it if we know more, if it was right enough. But for now, this is all we have according to the source. I'm going to stop the second camera. And at least right now, we're not going to do the upper possible planned video to the mirror symmetry. We're saying mirror symmetry is set up the same in the other way. Maybe we wait for a second source. Maybe here that is mirror symmetry. We're going to do a video. Maybe we're going to do it in the next video. Whatever. We're going to do it not now. So if you were here for particle physics, because that was particle physics, we can go directly to the next part of particle physics. We will do now the lunch training. If you then participate in the lunch training, then it's better the hours. So one leg up and one foot down. And the other leg up and point with the foot down. Take the leg at the ankle, make it straight back, and point with the knee down to the ground. Take the other leg at the ankle, make it straight back, point with the knee down to the ground. And heel onto the ground, pull the toes in, move the leg from left to right, the target now. Our heel onto the ground and pull the toes in, move the leg to left and right. And now to the lunges. The lunges. And let's do a lunge in front. So we're coming in front and back, another the leg. And the last time. And now to the standing lunges. So, 90-90 lunge, toe up with the back, and press with the hand against the outside of the knee. And up on the other side. 90-90 lunge, and press with the hand against the outside of the knee. And now 145 degree lunge, toe up with the back, and pull at the leg. And over to the other side. 135 degree lunge, toe up with the back, and pull the leg up. And over to the other side. 150 degree lunge, toe up with the back, and pull at the top of the shin bone. Over the 150 degree lunge, toe up with the back, pull at the top of the shin bone. And okay. And now, last exercise. Runner's lunge, so full lunge, toe up with the back, and pull it to the top of the shin bone. And out to the other side. Runner's lunge, toe up with the back, and pull it to the top of the shin bone. Okay. And now, stretching. One heel onto the ground, pull the toes in. Pull to the left and pull the toes in. To the right and pull the toes in. To the middle, move the leg from left to right. Other heel onto the ground, pull the toes in. Pull to the right, pull the toes in. To the left, pull the toes in. To the middle, move the leg from left to right. Feet together, breathe in, lift the arms up. Breathe out, draw the shoulder blades together. Breathe in and come up. Out and again down, draw the shoulder blades together. In and up. And out again down. Breathe in, bend the right knee. Breathe on and stretch the left leg. Breathe in and change. And out and stretch the right leg. In and change. And out and stretch the left leg. In and change. And out and stretch the right leg. In into the middle. And out just down. Then breathe in, come up. And out my hands down. Legs flat to the side. Breathe in, out. And breathe out again. Again in. And out. Breathe in, close the legs. And breathe again out. Right, for lunge training. Thank you very much, and next time.